it's going to be very hard to distinguish 10% from 5%. Okay, I actually did a homology model once, so don't try this at home, but I did a homology model once for a protein with sequence parent. Well, I had a query, and of course there was a template. So with 22% homology, identity between the two. So there was. It's sort of possible, maybe if you're lucky, but if you're unlucky, it could be all the way down here, right? If you have 30%, let's say 70% error in your alignment, you're going to make very interesting errors. Okay, so now talking about these errors, there are different types of errors, of course. So what does an error in alignment mean when you're comparing two proteins? So if you have, let's say you have two very distantly related proteins, a whole piece could be missing, a domain or a secondary structure element, which we say structure is more conserved than sequence, but at distant homology, there's also variations in the structure, right? As long as they don't affect the function of this protein, basically anything is allowed. So you can easily imagine that a peripheral helix that's maybe very prominent in one protein structure might get lost in a remote homolog because it's not really strictly necessary for the function of this protein. Right? So if you are going to align those two sequences, then you actually have to put the gaps there in the right place. You have to skip this helix, not the other one. Algorithmically, this is a difficult challenge to do. You have to balance aligning the residues in the right way, but also having a gap, and possibly a big gap, in some other places. Right? So, if you're thinking about homology searches, then you don't care too much about all the details of the alignment, as long as the alignment actually tells you something about the similarity of these two proteins, which relates to their homology, then you're happy. So the alignment could be incorrect, as long as the score is still good enough, right? Then you're already happy in terms of database searches. Everything always becomes more difficult if you're looking at remote homology, right? Because you can easily imagine if the sequence similarity is very slim, very low, then small changes in the alignment will also have a big effect on the alignment score, right? So that's going to be more difficult. Okay. I need to look for where to put a break, because it's sort of. Yeah, I do want to get a bit further than this. So, there's more to proteins than just the sequence, right? So, so here we have actually. Is this the same ones? Well, this is an example of DNA, and this is an example of a protein, right? Is that right? No, it's not right. This is just a set of letters, right? These are most of the alphabet, and you know this represents amino acids, which represent a protein. But even then, it's only the sequence. Yeah? Even if you know that this is a leucine, this is a aspartic acid, and a glycine, and serine, and so. Same for the DNA, right? There's no G's in DNA. It's a guanidine. It's a chemical thing, and even that doesn't tell you what it does. Right? It's a gross simplification of what we're actually looking at. Right? Of course, we do that because it makes it easy to access and search through all the data. Right? But it's just a representation, right? This isn't really a pipe. Right? This isn't actually really a painting. this isn't actually really a picture. It's the projection of a picture of a painting of a pipe. Right? So sometimes you're further away from reality than you realize. So this is not a protein. Yeah? This is not a protein. Okay. This is more of what we already said. So this is also not a protein. Yeah? I just want to be clear about that. It does include some detail about the protein that you can't see, and I'm not sure if it's the same sequence, the same protein, but it includes more detail or different details than what you see here, right? Oh, sorry, because here you can see that parts of the protein over here are close together, while in the sequence they are far away. Yeah? So you have your three-dimensional arrangement of your amino acid, which is shown here. But I can't see whether this is an arginine or an aspartic acid or a leucine. Yeah? So there's also other information left out. What you're actually doing when you're aligning, so these are actually three proteins, three different structures superposed. There could be more than three, but I think I only see three colors. Is that correct? Yeah. Okay. And what you're trying to do when you're aligning them is to make the corresponding residues between these three different proteins appear in the same spots or in the same column in your alignment, right? But it depends a little bit what you want your alignment for, but this is typically what you're aiming at, right? And there are also all sorts of interesting intricacies that you need to take into account when you're doing this. Okay. I'm not going to go into all of that detail. We have a course in February, structural bioinformatics, where we go a lot into structure analysis. But just to show you that this is in the protein. Okay. Right. So and it can become very interesting if you have big differences. So here you have two proteins superposed. Now they have the same set of colors, but the corresponding elements in both protein structures are colored in the same way. So you can actually see that there's two helices here. They're supposed to be similar. They're aligned on top. Here you see two helices that are sort of different. They're in the same location in the sequence, even in the structure, but they're oriented in a different way. Okay. This is probably quite remote homework, I would say. Okay, so
but the n terminus is not normally a loop.
Sorry?
The n terminus.
It's not a loop, I'm not sure what you're saying.
It's not a loop normally. Not a length.
Sorry, I'm not getting it.
So it's more difficult that they superimpose.
Oh, yes, but that's a different thing.
No.
Because this, yeah. Let's not get into that. Okay, so, let's see how much time I still have. Oh, right, that's okay. I think, well, next on the menu is to assess homology search methods. Well, that's not an entirely new topic to you guys either. So shall we do that before or after the break? After? Yeah? Okay.